So now we are finally solving equations involving radicals. And the process is the same as what we've done in the past as far as solving equations is concerned. The difference is that once we isolate the radical, the same way that we would normally isolate a variable expression, then we have to square both sides. When we do that, it's important that we check the answers, because when we square something, 3m plus 2 is not held to the same standards as the square root of 3m plus 2. With 3m plus 2, if we're not going to get a complex number for a solution with the radical, it has to be greater than or equal to 0. So we will check our solutions to be sure that they match the original equation. So with this problem, we're given the square root of 3m plus 2 minus 5 equals 0. So our first step would be to just add 5 to both sides. So then we've isolated the radical on the left-hand side. 3m plus 2 equals, the 5's cancel, and 0 plus 5 equals 5. So now is when we would square both sides to get rid of that radical. So now we have 3m plus 2 equals, because the square root of 3m plus 2 is just 3 squared is just 3m plus 2. And then 5 squared is 25. Now let's go ahead and bring this up here. If we subtract 2 from both sides, we get 3m plus 2 minus 2 is just 0 equals 25 minus 2, which is 23. And then we would finally divide both sides by 3. So m equals 23 thirds. As I mentioned, we need to check our solution, so let's go ahead and do that. Check. We do that by plugging it into our original. The square root of 3 times 23 thirds plus 2. That equals the square root of 23 thirds times 3, that's 23, plus 2, which equals the square root of 25, which equals 5. So we have this equals 5, which is what we originally started with, or we could subtract 5 if we wanted to as well. So minus 5, we want to know, does it equal 0? So then it's the same process from that point forward. 23 thirds times 3 is 23, plus 2 is 25. Minus 5, does that equal 0? 5 minus 5 does indeed equal 0. So both ways the solution checks.